Question 33. The following graph represents tidal levels in the Bay of Fundy over a 25-hour period. So it is a sinusoidal graph. You can see that the graph, it starts off at a low of 2 meters, and then it's increasing, reaching a height of 10 meters. And you can see that it actually goes through 2 full cycles by the time it reaches 25 meters. So it's not just one cycle, right? Low tide again, and then finally back to where we started at low tide. So what is the average height of the water? Well, the average height is occurring right here in the middle. And we all remember how to average 2 numbers, add them together and divide by 2. So we would just go 10 plus 2 divided by 2. So 12 divided by 2. Oops, I'm thinking of the answer here. 12 divided by 2 gives me 6. 6 meters. So if we want to put this in on our graph, 6 meters. So then the next part is what is the period of the graph? So we should recall for a sinusoidal function, the period is the length of one full cycle. So when we go period is your horizontal distance as well. So we cover 2 periods in 25 meters. So 1 period is 25 divided by 2, which is 12.5 hours. Okay, so explain what the period represents in this situation. It would represent, if we go back to our graph, right, it takes, if we just compare it to the start, it takes 12.5 hours to go from low tide to low tide. So that's what the period will represent. So I think that would be one appropriate answer. It takes 12.5 hours to go from low tide and return to low tide. What you don't want to say is high tide to low tide. High tide to low tide is half a period, which right would be 6.25 hours. Okay, so it's not required for this question, but we're only 3 minutes in. So I'm going to give the equation of this sinusoidal, because that is fun stuff. Okay, so let's go back up here and say the equation of this graph. They didn't ask us the equation, but a lot of times they will. So in any sinusoidal, we could do one of 2 functions. We could do a cosine equation, or we could do a sine equation. Now let's do cosine first, but there's a few things we got to know. A represents the amplitude. So in this particular graph, the amplitude, or any graph, it's the height from the center to the top. So we go from 6 to 10 meters. The amplitude is 4 meters. So amplitude is 4 meters. The 6, which you've already found, is the center of the graph, so that is our d value. The value for b is 2 pi divided by period. So b, I'll just put that here, is 2 pi divided by period. So the value of b is 2 pi over, what did we say, 12.5. So that's, so far we have 3 of these constants. A is 4, B is 2 pi over 12.5, D is 6. Now the value of C Depends on what trig function we're talking about. And the value of c in this case, when we're talking about cos, it's how far has the maximum moved over. So for cos, how far has this maximum moved over? What is the shift of that max? And if we remember, this is 12.5. This maximum is at 6.25, just half of 12.5. So the equation for cos is y equals 4, because that's the amplitude, cos b, which is 2 pi over 12.5. And you know, I'll probably do a t for time instead of x. And I'm running out of room here. Let's see if I can fix that. So nope, I can't fix that. So minus 6.25. And then we are going to have to close our bracket. Oh, can't see that. And then we want to add that center, which is 6. All right, I hope that makes sense. If we were doing the sine graph, sine is the shift of the center. How far has the center moved in? So that we're increasing through the center. So for sine, everything is the same except for the value of c. So where's the increasing center? And now, am I good at my halves? Half of a half, so half of 6.25 is right here. So that is increasing through the center. That is 3.125. So my equation for sine, everything's the same, and I'm going to have a little bit more space. Y equals amplitude is 4. My equation is sine. It's still, my b value is 2 pi over 12.5. Right, the period's not changing. And then it's t minus 3.125. And then I'm still out of room, but I gotta write plus 6. So I hope that is a little bit clear. It's a tough one. So if you have any more questions, ask your teacher. I'm sure they'll be happy to help you. The thing with using a cos to describe this, it's easier because it's easy to see the max. When you're using sine, it's not just the center. You want to make sure the point you pick is increasing through the center. So that's why we go with this first one.